Hi and welcome to Elaboration 6. So now I'm gonna do first part of Elaboration 6, which you can read here. It's a launch of rocket, and it's a three-stage rocket launched. Three-stage rocket that is launched, and I'm gonna measure its altitude, and I got the following measures, as you can see, that I'm gonna put into MATLAB: the times in seconds and the altitude in meters. So I'm gonna start right away. I'm gonna do the times here. Which we have from 0 to 24. And the altitude is here, as you can see. It's gonna take a long time for me to write this, so I'm gonna copy it from the elaboration itself, elaboration PDF. Then we have 107.37. And then we have 210. 210. Yeah, this is gonna take a while. Yeah, this isn't very funny to do, but there's no choice than to put all the numbers in the brackets. almost done here. Putting in altitudes, meters. Yeah, only 2 numbers left. And then we have the last number here. Oh, there's an extra bracket here. Yes, now it's alright. And what collaboration want me to do is I'm gonna create a plot with time on x-axis and the altitude on y-axis. So that's what I'm gonna do. I'm gonna plot times and altitude, times, comma, altitude, and then I'm gonna give it a title. I'm gonna give it rocket launch as the title. I mean, I'm gonna give it rocket height because this is the altitude, so rocket height, and then the X label here is a time in seconds. The Y label is altitude in meters, altitude meters, and then it says that I need to use the diff function to determine the velocity, which is the speed during each time interval, and plot the velocity against the time. So I'm gonna do velocity equals diff of altitude, and I'm gonna call this as A. I'm gonna call diff velocity as A. Difference in velocity. Velocity. So going to be a big V here. And now I'm gonna So now I plotted times altitude, now I plotted the times and velocity. Times velocity. And the title of this is rocket speed. I'll do it. Rocket speed. The title. Rocket speed. And the X label here will also be times in seconds. So I forgot the S here. So the X label here is also times seconds, and the Y label is the velocity in meter per seconds. Sorry, I forgot to do the apostrophes. So now I plotted the velocity as well against the time. So what I'll do now is I'm going to use the diff function again to determine the acceleration during each time interval, and I'll plot this also against the time. Times comma acceleration, which was a here, because the acceleration is the difference in velocity. I will have this title as rocket acceleration. And the X label here will also be as the before ones, times in seconds, times, seconds, and the Y label will be the acceleration. In meter per seconds powered up to 2. So what I will do next is I'm gonna plot the times against the velocity and the times against the acceleration in one plot together, so I get one figure for both of them, and then I'm gonna run the code and I'm gonna show you what I get. So So to put both of them in one figure, times against the velocity against the time, and the acceleration against the time, I'm gonna do that by writing in both of them, as I did here in plot, this plot, and this plot, but together in one plot. So what I'm gonna do is simply gonna take this here, gonna paste it into here, and then I'm gonna do the same with the acceleration against the time. And now I'm gonna run it. Yeah, we can call it M6.1. Yeah, so I plotted, so I run it, and this is what I got here. And if we take a look at what we got in the beginning, here we can see that this is the times from 1 to 24, from 0 to 24. So I used linspace instead of writing all of them, so it gives me 25 numbers between 0 and 24. And then the altitude is here, as you can see. It's timed by 1 times 10 power up to 3 times the numbers here. It gives us these results here. You can see that altitude. And then we have the velocity, which is the difference in altitude. And then we have the acceleration, which is the difference in velocity. And if we take a look at times, if we take a look at figure 1, we can see that for both the velocity and for the acceleration, and the staging time, you can see here, estimate the staging time, the time when a burnout stage is discarded and the next stage ignites by examining the plots you have created. So the velocity here is the blue line. So the staging time here is between in the blue line. Doesn't give a very clear, but it's between 22 and 23, the staging time for the velocity. And for the acceleration is between 15 to 17, the staging time. Yes, so this is the result that we got, and thank you for this video, and I'm gonna go through the part 2 and part 3 of the elaboration 6 in another video.